Okay, so we're going to show some of how we do the analysis of the data once we have measured the photometry. And just since the last time, I just click these stars. I don't know that we're going to end up using all of these either. Some of them are quite noisy. So we'll just leave it as 1, 2, and 3 right now. And I can't remember how to auto scale. So we'll leave that. Okay. Oh, I think it's here. Maybe we can redraw. Yeah, so redraw the plot there. Okay. All right. So we have to set up some parameters here in the main plot menu. And if I just look back at the transit information that we had from the Swarthmore site. So again, here's our hat P44B. This was the day that we were looking at the transit, and it's saying that this is from observing from Siena College. And then here, it's giving us the Julian date for when it started, the mid, and the end. And so we need to tell this where it started and where the transit started and where we think it ended, because it's going to try and detrend data based on this. So, all right, so we said the point, so 9348.58 is where it was starting. So our left marker, we want to make at point, hold on, left will be, 0.58, and we actually want to show this. Oh, 0.58. All right. So this is the left marker. So you can see that we did not get a lot of data before the transit started. Our right marker is going to be when we think it ends. So that's 48.71. So I can go over here. I'm going to, oh no, I'm not going to trim, but I'm going to make this a little bit bigger, 0.71. Okay. So then we expect that the transit's happening between here and here. Okay. All right. So next we want to go and try and detrend the data for a few things that could be affecting the brightness that we measure. So one is the air mass. So as we're observing, our air mass is changing all the time. I believe this one was still rising. Actually, we can look at what was happening in the air mass plot here. Look at that. Yeah. So it wasn't changing a ton, but during the transit, right, it was still rising, so getting higher up in the sky, and then it was starting to get lower. So this is telling us how much of the atmosphere we're looking through, right? Where one atmosphere will be looking straight overhead. As you start looking at angles, you're looking through more air, and so you end up losing some light because of that. So we want to correct for that term. Okay, so we can detrend the data. And so here, there's actually 3 ways that we can try and detrend the data. So I forgot, actually, I'm gonna bin the data as well. So let's at least do 2 by 2. And that will bin neighboring points so that the data look a little smoother. Kind of helps get rid of some of the bouncing around of the noise. Okay, so we want to, so this is kind of interesting too. So it's telling us, these little icons here are telling us, do we want to fit to the left of where we think the transit is, to the right of the transit, right? So here's like before and after, or fit all the way through it, or actually try and model the actual transit. So for the target object, for the actual air mass term, we want to fit before and after. We don't want it to worry about what's happening during the transit. And we want to detrend the data by air mass. Okay, and then we can add that to this guy as well. For the comparison stars, we can do all the way through because we're not expecting their brightness to dip during the transit. So we can do that and then take the air mass out of that. Okay, and then we can add a second term that may not be necessary, but we could try it, and that is just with the time of the observation. So we'll try it. We'll put in the UTC, the universal time of the observation. Again, for the target, we'll do before and after, and then we can add it to these guys too. The second term will be the UTC. UTC. Okay. And then for this guy, for the target, we're going to add one more, our third term, which is actually going to be fitting the transit properties. Okay. All right, and once we do that, we get another window opening over here. And there we go. That's fit the transit now. Let's see if we can zoom out a little bit. So there we go. So we don't have a ton before. It's fitting the transit and then coming out. Okay, so I didn't add this yet. Again, we could show, let's see. Ooh, that's a mess, right? So it's actually trying to normalize the data using these other stars, and that star looks to be pretty much a mess, probably because it's just too faint. So let's look at how this one looks. Still pretty icky. And 6 seems not as bad. So maybe we'll leave 6 in, and we'll detrend this one as well. Again, it's a comparison star, so we can use all the bins. So we'll first do air mass. We'll second do the UTC, the observation, and that's it for the comparison stars, right? We don't want to fit a model to them. Okay, so now we have our fit. So this is showing us the parameters of the fit here. So interesting things like it's got the radius of the planet divided by the star squared. I believe that's the semi-major axis, the temperature, inclination, all that kind of stuff. So it asks us actually to put in what we think the parent star is. And again, if we go back to this awesome Swarthmore page, we can find some of the some more information. So if we click on hat P, oh no, it's going to show us that. Okay, hold on. Oh yeah, so we want to go to the exoplanet archive. I'm sure it'll come up in a sec. So it actually has some information that we can compare to, which is cool. But it also tells us, it should tell us somewhere about the parent star. But anyway, you guys can look around for that. It's up here. B. The star. Blah, blah, blah. Yeah, okay, so here it's giving us the effective temperature of the star and luminosity. Anyway, it's pretty close to a solar type star. And you can see that there are some measurements reported that are probably pretty consistent with each other. So we can use that in when we're doing our model. So it's saying it's a G5. Let's see, G0, let's say hotter. So G5 is probably fine. Maybe it's a little bit cooler than this, but again, for now, it's fine, right? We're just figuring out how this works. Okay, so the other important thing here, right, is this window, which is saying what are we using as the reference stars? Because it's taking, it's actually trying to, at every point that we measure the brightness of the star that's undergoing the transit, it's measuring the brightness of all our other comparison stars and trying to correct for any variations that might be going on with everything in the field of view, right? So like if everything gets brighter or everything gets fainter, that's, maybe something wrong with the camera or a cloud went by or something like that. The transparency changed briefly. So it's trying to correct for all that with these other comparison stars. But so you can actually go through, so actually this is kind of fun because you can do, so right now everything is selected as a reference star, right? And you can kind of cycle through with dropping one of these out and see what happens to your exoplanet curve. Okay, so now it dropped out 3, and then it's going to drop out 4, and then it's going to drop out 5, and then it's going to drop out 6. So you can kind of look at that, right, and see if there's any one that might be throwing off your measurements. And then you can even try this of just using individual stars. Like if we only had one comparison star, what would our model look like? So there's comparison 2, comparison 3, comparison 4. Oh, that looks terrible. 5 and 6. So we don't want to just use one comparison star, right? We want to pretty much have them all. Let's get them all on. And then you can kind of go through and see if there are some combinations that give you the best. Remember, we had said probably these first two are, might be some of the good comparison stars. But you can just kind of play with it and see how things change. Gives you some idea of how reliable your estimates are for the star of the sun. It's like the size of the planet and all that. So it's a good way to kind of maybe estimate what their error is on these parameters. Okay, so that is pretty much it. I'll stop recording there.